So,
do you have notes for
I gave them to you.
no for like the recording?
It's on Canvas.
Oh, okay.
It should be on Canvas. All right. So deviation is the value minus the mean. How far away the value is from the mean. So one time we're going to find standard deviation by hand because I want you guys to kind of understand where it comes from and what it is. So deviation. So if I want to know how much something deviates from something, to deviate is to go away from, right? So you in math, it's just a difference between the average, but in other aspects, like if you deviate from society, that means you're kind of going off from society. So to deviate is to go away from something. So the standard deviation gives us an idea of how far most values are from the average, from the mean. So to find standard deviation for data, you will find the mean, find the deviations, square them, add them, divide by n minus 1, and take the square root. So I told you we're only going to do this one time by hand, and the calculator will do it for you, but I want to walk through it one time so you kind of get the idea of what's happening. It is not that bad. We got a worksheet for the next thing. The formula looks like this. I just put it up here so you could see it. It's not something that we're going to use, okay, that we're going to have to do. So I need everybody, rulers, to measure your hand span. That's going to be the length across your hands. Let's do centimeters because they're easier to measure.
Are we doing inches or centimeters? Okay. Mine's about.
All right. So you're going to, the easiest way to do this, guys, the easiest way to do this is to lay your ruler down on the desk. Put your thumb at the 0, so you're going to lay it on the desk like this. Put your thumb at 0, try to stretch your pinky as far as you can. Okay?
Is that 13?
So put your thumb at 0.
It's to 18.
You can stretch further than that. Stretch.
Okay.
17. Okay. All right. I'm going to actually put this into Desmos first because we're going to. So you guys don't need to put this
Is this
in.
what y'all hit people?
Unfortunately, no, I've never.
Did you ever like slap your hand? I got hit with a wooden spoon.
I never got one, but some kids did.
Like I'll get where they get that spoon.
It was on its way out then. They didn't use it very much. So then.
How actually do they hit people?
All right. Okay. Okay. Wade. Hand span. Okay. Caroline. Okay. Zane. Passion.
17.
All right. Peyton. 20. That was 20. I'm going to add that in there. Okay. So, we're not going to do standard deviation with all of these because that would be a little bit difficult to do. So, we're going to choose, I don't even know if I really want, I guess we'll pick the 6 smallest here. So, alright. Alright. Okay, so we're going to choose 6 smallest. We'll see, we got a 17.5, a 17. Nobody was. Another 17. Sorry. 18. And, do I have 18? Alright, so 18, 19. Okay. Alright. So, even though, hold on, yours has a chart, right? Where's my chart? No? Did I open the wrong, I think I opened the wrong thing. Alright. But you have a chart after that, right? Alright. Let's see, I think I might have. Let me try this one. Okay, this one has the chart, but has the answers on it, so. Alright. Let's see. Sorry. Okay. Alright, so for our class, we had 2 17s, a 17.5, an 18, and 2 18s, and then one of our 19s is going to be our next. Yeah, you will. It's going. This is for the 6 smallest right here, and then we'll do the largest. Although we may just do once. So we have to do standard deviation. So you get an idea of what this is. Standard deviation is going to tell you how far away your data is from the average. So we're going to find the mean of these 6 numbers. Okay, so everybody with your calculator, I want you to find the mean of these 6 numbers here. Yeah, mean is your average, yes. Yeah, so put 17.75 everywhere here. I think you did not hit enter before you divided properly. Oh, why is it doing that? This is so hateful. Right, you gotta divide. So the mean goes here for all of these. All right. Okay? All right, so we need to now calculate the deviation for each data point. Deviation is the number minus the mean. So like for this first line, I do 17 minus 17.75. That's going to be negative 0.75. And I'll get that twice, actually. I'll get negative 0.25. It is possible to get 0, but we won't here. Then we'll get positive 0.25, positive 0.25, and 1.25. So we're just taking, this number 17 and subtracting 17.75. Gives you negative 0.75. Yes, that's what we're going to do here in a second. Yeah. So, now, if I tried to add all those numbers together, what do I get? Try adding all the deviations together. You get 0. Right. Because some of these numbers are above the mean, some of them are below. If you've done it correctly, you should get 0 right there. So just adding up the deviations wouldn't tell us anything about our data because you get 0 every single time if you've done it correctly. So they had to come up with another measure that would tell them how spread out their data is without getting 0, because 0 doesn't tell you anything. So if we square each one of these numbers, it'll get rid of all the negatives, right? So if I do 0.75 squared, it's going to give me 0.5625. All these 5s, this thing can't write 5s for some reason. It's so annoying. It is. So we'll get 0.5625 for both of these. We'll get 0.0625 for these 3. Five, 6, 5, 2, 5. 5, 6, 2, 5, if I got that right. Okay, so this time, if I add all those numbers together, I got 4.5625. I'm getting 4.5625. Because 7.5 and 18 are the same distance away from your mean. So like when you do the deviation, whenever you subtract these, you get negative 0.25 here and you get positive 0.25 here. But when you square it, it gives you the same value, because when you square a negative, it becomes positive. Maybe I did it wrong. Oh, I think I didn't have my 0 there. You're right, Kate. 2.875. Now, what we've got here, now we at least have a number, right? But if we had a really big data set, it would look like that number would be really big because we'd add a bunch of them together, even if most of the data points are really close. So we kind of need to undo the stuff that we have done. So since we've got 6 data points, we're going to divide. I can't remember from statistics class exactly why, but they divide by n minus 1. So for whatever reason, they divide by 5 instead of 6 here. So we're going to take that number and divide it by 5. So we won't get caught up in y so much for that. 5, 7, 5. And then we take the square root to undo squaring all of those. So if we square root 0.575, we'll get 0.758. 2875. So that would be standard deviation. Now you don't have to do this by hand, huh? Yes. And you're not going to have to do this by hand, but I kind of wanted to do it one time just to see the process, to see how you're looking at that deviation, how far the numbers are from the mean, right? So, like, for example, whenever you get a test grade back, you probably, you might hide it and not want anybody to look at it, but a lot of you, I see you start talking to everybody else, and you're like, what did you get? What did you get? What did you get? Right? And you kind of keep, in your mind, you're thinking, oh, what about did everybody get? And then you're comparing yourself to it. Did I do better or worse than what I'm seeing, right? So if you know the average, you're looking at your deviation. If you have a positive deviation on the test, that's good. That means you did better than average, right? But if you have a negative deviation on the test, that means you did worse than average. That's not good. So you take those deviations, and standard deviation tells me how far away is my data from the mean. It squares it. It manipulates it so that you get a positive number. So standard deviation tells you how spread out your data is, right? If I give a test and everybody makes an 80 on it, then my standard deviation would be 0. There would be no variation. Everybody makes the same, right? If my highest grade was 70, my lowest grade was 70, my highest was 90. My standard deviation, I would have some standard deviation there, right? It'd be something positive. But if my lowest grade was 20 and my highest grade was 115, what do you think would happen to that standard deviation? It'd go up, because those numbers, like if you made the 20, your number is way far away from average, right? Or if you made the 115, yours is far away from average. So as deviation numbers get bigger, which makes the standard deviation bigger. So we're not going to do the second one here. So let's look at these. Let me erase this. Okay. So which group would have the highest mean and the highest standard deviation? So if we looked at the heights of the Chicago Bulls players and the heights of all people in Chicago, which group is going to have the highest average height? Okay? A, because we would assume that the Chicago Bulls players are going to be taller than just the average person in Chicago, right? Because average person in Chicago includes all kinds of people, right? The people in Chicago are not exceptionally tall or anything. They're probably some really tall people, some really short people, but average, right? But the Chicago Bull players, we would expect them to be taller because typically professional basketball players are taller than average people, okay? Now, which group would have the highest standard deviation? Okay? You have more people, which means your data is much more spread out, right? Because the Chicago Bull players live in Chicago, at least for part of the year, probably, right? And so they're included. Those super tall people are included. But you also have, the way this is worded, even children, right, that are going to be really short. So it's going to be really spread out. So this would have the highest standard deviation. Right, so a lot of questions you're going to get on the exam for this are not even going to actually have numbers in them. They're just going to ask you to reason through them. Okay? So answer number 2 on your papers. So, for number 2, what do you guys think? Which group is going to have the highest mean, and which one's going to have the highest standard deviation? So let's do standard deviation first. The prices of homes in Elkin only, or in all of North Carolina. All of North Carolina, that's going to have the highest standard deviation. All right. What about the highest mean? I don't know. If Elkin was a place that was clearly richer than other places or clearly poorer than others, then we could make a decision here. I am not sure how Elkin compares to the rest of North Carolina. Now, this is not a poor area, significantly poor area. It's also not like if instead of Elkin, if I change this to like Lake Norman, I wouldn't even do Charlotte, because Charlotte would also include, poorer areas of Charlotte. Although Charlotte still may have higher overall, but I'm talking like a place known for rich people. If we looked at like Lake Norman, and I'm talking like the people who live on the lake, sort of Lake Norman, like. That, yeah, Mooresville in general is probably going to have a little bit higher than the rest of the state. And parts of Charlotte are definitely going to be, but not necessarily all of Charlotte, because Charlotte is going to be a place that has parts that are more affluent and less affluent. So I'm going to leave this up in the air, because I'm not really, this is something, somebody see if they can find an answer to this. I'm not sure how Elkin compares to the state as a whole. Because I know there will be places that have much lower standards of living than Elkin, but there's also places with higher. So I'm not sure. We might actually end up being pretty average. I'm not going to spend time right now because we're almost out of time. But yeah. All right. So which group should have the highest mean, and which one should have the highest standard deviation? The weights of newborn babies, the weights of NFL linemen, and the weights of people at a church cookout.
I don't know. Church cookout people can be pretty big.
Okay, all right, so for mean, there's one we can definitely rule out. Newborn babies, right? And unless I feel like on average there might be some hefty people in line at the church cookout, but I don't think it's going to be everybody. I think linemen are going to have it here. So their mean is going to be the highest.
I think standard deviation can be, you have babies there, you have moms,
Right.
old people there.
So I agree. Standard deviation goes to the church cookout
Because most babies are between like 3 and 8 pounds.
because it, more than likely will have some kids, some adults, some skinny people, some fat people, some, all the way in between. I tried to pick something that would just have a wide variety of people at. So standard deviation would be higher there. All right, so we're out of time. We'll finish this tomorrow.